Welcome to section 2.2, Numerical Patterns in Nature. The best way to use these videos is to take lots of notes, pause the video often, and re-watch and rewind. Question of the day. Pause the video here. What is the next number in the sequence? Pause here, give it a try, and press play when you're ready to see the solution. So this pattern here, if we were to keep going with it, and actually I'll pull it from here, is that we're adding the previous numbers together. 1 plus 1 equals 2. 1 plus 2 equals 3. 2 plus 3 equals 5. 3 plus 5 equals 8. And so if we were to add these two together, we would get 34. And so we can continue the pattern here, 34, we add these two together, we get 55, add those two together, we get 89, and this pattern continues forever. So we can actually go reverse. What numbers came before, and how many numbers before 8 exist? So in this case, we would subtract these two numbers to go in this direction. So you can move forward and backward with this pattern. So now let's pause here. How many spirals do you see in this pineapple? So just pause the video here and see if you can count the number of spirals. And I'll just show you that we're kind of counting like this is 1, this is 2, this is 3. And we're going in that direction, and you can go the other direction too, 1, 2. And while you pause here and try and draw on your paper, you can also look at pine cones. And when we look at these are just two different angles. We're counting the spirals. So that goes to that one, that goes to that one. And you can also go in the other direction. Oops. So take a moment here and just see if you can count the spirals. And when you're done with that, I actually want you to pause this video and go watch this YouTube video and come back after you've seen all the different ways that you can count spirals. So now that you're back, let's look at the spirals here. So again, when we count these, we see that you get 8 in one direction and 13 in the other. So again, when you count these spirals, you got 1, 2, oops, you're going to end up doing this in your discussion boards. There we go. Just want to be super careful counting your spirals. And again, you can go in the other direction. So when you do this, you realize that you get 8 in one direction and 13 in another. Interesting. How about with pineapples? When you go one direction and the other, and you saw all this in your video. And so what these are these are the Fibonacci, and I'll say Hemachandra numbers, because these actually originated in Sanskrit poetry long before Fibonacci. I'd say rediscovered these. So if you actually want to see how these connect with music, poetry, beats, I would encourage you to watch that YouTube video. But we call the sequence that we discovered and that we talked about in the first one, these are the Fibonacci numbers. And if you actually look at the way they grow, they create a spiral. So if we make a 1 by 1, 1 by 1, if we make a 2 by 2, a 3 by 3, a 5 by 5, we get this cool, and it will continue on forever. And so that's why Fibonacci numbers are related with spirals, and we can see them in our nature in the number of petals. We can see them in food, all over in different foods, and we can even see them in nature. So when we look at this, we see that the pineapple has 8 and 13, and the daisy has 21 and 34, and there is a pattern here. When you've got spirals occurring, these Fibonacci spirals occurring, there are always going to be these consecutive numbers. You're going to have 5 and 8, 8 and 13, 13 and 21, 21 and 34. It's very interesting. So let's talk about the way bees reproduce, because it actually comes out in a Fibonacci number. Or excuse me, a Fibonacci sequence. So one queen lays all the eggs. So one queen lays all of the eggs, and a couple things can happen. She can have a egg without a male. It's not fertilized. So there's only one parent, and the result will be a male drone. Okay, but if it's created with a male bee, so if it's fertilized, the result will be a female worker bee. Okay, so these male bees have only a female parent. They only have the queen. And all female worker bees have a male and a female parent. Okay, that's how bees reproduce. So if we were to look at the family tree for a male bee, okay, so a male bee has parents. What are his parents? We know that he has a female parent and only a female parent. But what about his grandparents? And I know we're talking about bees here, but stick with me. Well, we know females have a female and a male parent. So what about the great-grandparents? Well, all females have a female and a male parent, and all males just have a female. How about a great-great-grandparent? Females have a female and a male parent. Males only have a female, and females have a female and a male parent. What have we got here? 1, 1, 2, 3, 5. If we kept going, this would continue in Fibonacci, and it actually works the same with females. If we were to start with a female bee and look at her parents, we know that a female has a male and a female for parents, and a male just has a female, but they have a female and a male. 1, 2, 3. A female has a female and a male, female and a male, and just a female. 1, 2, 3, 4, 5. And we could keep going. And if you want to see it, here's some charts as well to help you visualize that. So we can actually, there's this very famous puzzle called the Fibonacci Bunnies puzzle. And it goes like this. Suppose we have a pair of rabbits, a pair of baby rabbits. So we start with babies, one male, one female. So rabbits can not reproduce until they are 1 month old. And then after that, they have a 1 month gestation period. So once they start reproducing, they produce a pair of bunnies each month, one of each sex. Assuming that no pair ever dies, how many pair of bunnies will exist in a particular month? All right. So this is what we're going to do. We're going to call open circles are going to be our babies. And closed circles are going to be when they're, able to reproduce or when they're parents. So in month 1, they're babies, right? They were just born. Okay. But in month 2, they grow up. They could become parents. They're not actually parents yet, but they're mature. Okay. Now in month 3, they start reproducing. They have 1 pair of bunnies. So they come through. Month 3, they still exist, right? But they produce another pair of bunnies. Now in month 4, they still exist. They're still alive. But they produce another pair of bunnies. And this pair matures. In month 5, they still exist. And they produce another pair of bunnies, and they grow up. This pair grows up. Now they continue to live, and they have a pair of bunnies. And this continues on. Let's look at this. 1, 1, 2, 3, 5. We can make the Fibonacci continue. We can make predictions. Here's another image of this if it helps you to look at the images as well, and this comes from your textbook. So we're going to pause here, and when we come back, we're going to continue to ask what else can we do with Fibonacci numbers.